this way, when I'm done with taking pictures with my digital camera, all I have to do is to plug in the compact flash card or SD card to the flash reader that is already on the computer itself. So that's a nice setup. There's plenty of interfaces here. ATX form factor, so this is spelling out the exact size of an ATX form factor, which is typically a little bit bigger than a letter-sized piece of paper, just a little bit wider and a little bit taller. No, it's not really that much taller. It's just wider. Features provides newest Marvel SE9128 high-speed SATA 3 storage interface with super fast 6 gigabit per second link speed, blah, 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 blah. And it supports ATI Crossfire X. So that tells me that you have two 16-lane PCI Express slots, because otherwise there's no need to talk about Crossfire. Are there any questions at this point? Yep.
Yeah, what did the P55 stand for at the...
That's the chipset number from Intel. So if you go look for Intel P55, it basically tells you what the chipset is about. And here is this page specific to the P55? Yes, it is. Okay. So desktop PC platforms based on the Intel P55 Express chipset combined with the Intel Core i7-800 series processors and the i5 700 series processor to create intelligent performance for faster multitasking, yada, yada, yada. And features. Matrix storage technology with additional hard drives added. So this chipset automatically can support RAID 0, 5, and 10. With proper, software driving. Okay, and greater data protection against a hardware failure. It can also implement RAID 1, which is the simplest case of mirroring a hard drive. RAID 5, which combines both mirroring redundancy and also extending the storage capacity, and also RAID 10. Support for external eSATA. Enable the full SATA interface speed outside the chassis up to 3 gigabits per second. Rapid recovery technology. Okay, I think that is a software-driven type of approach. Latest data protection technology provides a recovery point that can be used to quickly recover a system should a hard drive fail. Well, many times when a hard drive fails, there's no way to recover the system unless you have a RAID setup. High definition audio, we talked about that already. Universal serial bus, this one has up to 14 USB 2.0 ports, which is also telling me that the USB 3.0 part is offered by an external chip, a chip that is external to the P55. Serial ATA connections. So the 6 serial ATA 3 gigabit per second interfaces, they're all coming from the P55 directly. But the other two 6 gigabit per second interfaces, those are coming from a separate chipset, the Marvel chipset. PCI Express 2.0, which is a fast speed. This is the bandwidth of a PCI Express 2.0 interface. It stands for 2.5 giga, what is the T? Transfer. Okay, it's giga transfer per second. In other words, it can perform 2.5 billion transfers per second. Now, how many bytes are you transferring per transfer? That depends on how many lanes we are talking about. Remember, we have the 16-lane type of PCI Express cards, so that means each time we transfer, we're transferring 16 bits. If you have a 1-lane type of PCI Express card, that means we're only transferring 1 bit at a time. And I'm just reminding myself to pass around the row sheet for today. Put your name, write your name or just initial next Q&A. And then we have the network card. But this particular motherboard is also specifying that it uses the Realtek Ethernet connector, so it's not even using this one here. Okay. Any other questions? Now that we have specified the motherboard, what else do we need to specify?
RAM, maybe?
Maybe the processor?
Oh, the processor.
Yep. Okay, so the next thing we need to look at is the processor. This is actually the note from last time, so I'm just continuing with what we had last time. So we go to computer hardware again, and this time we go to processors or CPUs. We already know we need a desktop type of processor, so we can go straight to desktops. We already know this is going to be an Intel processor. We go to Intel. And we already know that we either want an i7 or we want an i5 type, or we can select by the socket type. We already know this is a 1156 socket type, so we click that. And you can see how the interface of Newegg is kind of user friendly. You can kind of narrow down your choices pretty quickly. Here is an i5 750 Linfield 2.66 gigahertz quad-core processor. And last time we already talked about quad-core versus dual-core, because sometimes a dual-core processor can cost more than a quad-core processor. So in this case, this is a 65 nanometer process, which means it is an older type of process. It consumes more power. 45 nanometer, this is a 32 nanometer, which means it is a smaller core, smaller transistor size, and it is, how much is it? This one is $113. It runs at a higher clock speed too, with 4 megabytes of cache. The other two have 8 megabytes of cache, but that's because they are quad-core processors. And let's see what other choices we have here. We have this is an i3. Here's an i5 again, but it's also using the 45 nanometer process. Another i3, an i5, and this one uses the 32 nanometer process, which is great. i7 using the 45 nanometer process, 45 nanometer process, 32 nanometer process. This one is running at an even higher clock speed at 3.33 gigahertz. And how does this one compare to the other one? The price is off by $2. The model number is off by 1. I cannot see any actual differences here. Okay. And this one runs even at a higher clock speed. Now, can you guys see how much, what is the big jump here? From 3.33 gigahertz, it costs $210. If I bump up the speed to 3.46 in gigahertz, the price goes all the way to $300. I'm paying almost $90 more, just for a fractional increase of the clock speed. Is it worth the price? Probably not. Okay. And then we have an i5-655K, 4 gigahertz, 3.2 gigahertz for $200. Also using the 32 nanometer process. And here we have a Screamer, 3.6 gigahertz, even faster. Also using the 32 nanometer process. So what you need to do, is to look at, I would look at the amount of cache first. Okay, but since all of these have 4 megabytes of cache with a dual core processor setup, they're all about the same. Once I know how much cache it has, I would look at the manufacturing technology. 32 nanometer is better than 45 nanometer process. And then you want to look at the product line too. i5 is better than the i3, and i7 is better than the i5. And here is a slightly more expensive one. It's also using the older, 45 nanometer process. The clock speed is lower, Okay, because it is only 2.53 gigahertz. Now, here we don't have a clear winner. In other words, I can't really tell you, okay, always go for a quad-core processor, even though the clock speed is lower, but you have 4 different cores inside, or go for a dual-core processor that is running at a higher clock speed. Because it all depends on what type of software you're going to use, and also how you're going to use the system. If you do a lot of transcoding, then you definitely want to get a quad-core processor because all of the processors will be kept busy all the time. On the other hand, you just need a general machine for office, browsing the web and stuff like that. A dual-core processor is more than sufficient. So now it all depends on what you're doing. It also depends on what kind of games that you play. If you play a game that specifically says that it can utilize a quad-core processor, then you want to get a quad-core processor. How many games do that? None. So most games cannot really benefit from a quad-core processor. Is that what the common sense is saying?
A lot of games start with quad-core.
So the quad-core, they can utilize the extra cores. So here I don't really know, exactly how to evaluate, and recommend, the products. Does anyone want to say anything about, these choices amongst all the Core I processors? No. Now, one thing you can also do, if you're running short in terms of money, or there's one particular item that you like, but you don't have the money at this point to buy the high-end processor that you always want. For the longest time, I used a Pentium. What is the name? I use a Celeron. Okay, for the longest time, I use a 775 socket Celeron processor, which is one of the worst processors you can get. Okay, it has a lot of heat dissipation, close to 100 watts, and the processing power is really low. It's a single core processor, but it was cheap. I bought it for like $50 or 30 something bucks. So I was able to use my system even though it was slow. But as soon as the quad-core processor price, got down to like 200 something, I jumped on it. So that's one thing you can do, is to go for a lower-end processor first, like an i3, 350, which is already dual-core. I mean, this is already a dual-core processor running at 2.93 gigahertz. The cache size is already 4 megabytes. So you're getting most of the stuff that the higher-end processors, have, but you're getting it for a price that is about 1/2 of a higher-end i5 processor. So that means, if this one is what you need, you can run it, for a while. In a year or so, when the price of the higher-end processors, come down because Intel releases, more powerful processors, then you can upgrade again for another $100 or so. So that's one way of looking at it. The other way is to say, okay, I want the higher end version now so I don't have to upgrade later. So it all depends on how comfortable you feel about upgrading your processor once in a while. Any questions about these items? No questions? The other thing you want to do is to read the comments. Okay, if you suspect an i3 530 is a weak processor, you still might want to spend some time to read at least some of these 184 reviews, because someone may post something that says this is already more than sufficient to play a specific game that you want to play. Okay? Or this is already more than sufficient for most tasks. Why pay $100 more if this is already more than sufficient? Any questions so far? Does anyone want to know, how Intel comes up with all these, different product lines? Do they actually have all these different processors when they make it? No? No idea? The answer is no. Yep.
Well, didn't they use the way they downgraded the processors was they tried to create the higher end